Welcome to Lesson 7.3, Solving Linear Systems by Elimination. Now, realize in your book, this section is titled Solving Linear Systems by Combinations. We can interchange the terms elimination and combinations. They are the same process for solving linear systems. So if you call it elimination or combinations, it means the same thing. So when we are looking at linear elimination, we have 5 steps to follow to get through the system of equations. The first step is to line up like terms. So that means line up the x with the x, y with the y, the constant on its own with the constant, and we line it up vertically. So we would want the x above the x, the y value above the y, the number above the number. Then in step 2, we want to get coefficients opposite for one variable. So it doesn't matter which variable you pick, but you're going to end up in some of these equations multiplying one or both equations by a value, so we get opposite coefficients. For example, a 3y and a negative 3y, or a 7x and a negative 7x. The reason we want the opposites is for step 3. Once one of the variables are opposite, we can add the two equations together, and that allows us to solve for one variable. Once we've solved for one variable, we substitute that answer back into one of the two original equations and solve for the second variable. So you're taking whatever you get from step 3, so let's say we solve for x, and you're going to substitute that value back into one of the two original equations, doesn't matter which one, and then solve for the other variable. So if we already had x, we'd be solving for y. And then just like our other 2 lessons on linear systems, we want to write our final answer as an ordered pair. So for example, x comma y. If they're different letters, you want to list them in alphabetical order. So it'd be like A comma B. So 5 steps. Now you'll see there's no graphing involved. So let's take a look at how to get through these 5 steps. So in example 1, step 1's already done for us. They lined up the x's above each other, the y's, and the constants. Step 2, we want to make sure one of our variables have opposite coefficients. So here, positive 3y and negative 3y, they have opposite coefficients in front, 3 and negative 3, so step 2 is already done for us. So then for step 3, we're going to add the top and bottom equation together. So what ends up happening is 4x plus 2x is 6x. Positive 3y plus negative 3y cancels, which is exactly why we want opposite variables. And 16 plus 8 is 24. So what we're left with is 6x equals 24. Divide both sides by 6, and we get x equals 4. So now we're moving to step 4. We're going to take the answer, x equals 4, and substitute it into one of the original equations and solve that for y. So I'm going to use the top equation, 4x plus 3y equals 16. So 4x plus 3y equals 16. I'm putting in a 4 for x. So 4 times 4 plus 3y equals 16, meaning 16 plus 3y equals 16. So to solve for y, subtract 16 from each side. 3y equals 0, divide by 3, and 0 divided by anything is 0. So our final answer would be x equals 4, y equals 0. So we'd write it as the ordered pair, 4 comma 0. So let's now look at example B here. In B, steps 1 and 2 are already done for us. The x's, the y's, and the numbers are lined up vertically. And the x's are already opposite values, negative 1x, positive 1x. So I simply need to add my two equations together. So 2y plus 6y is 8y. Negative 8 plus negative 16 is a negative 24. Then what we want to do is divide both sides by 8, and we end up with y equals a negative 3. Now we're going to take the y equals negative 3 and substitute that back into one of the two original equations. So I'll use the top equation. So I have the opposite of x plus 2y equals negative 8. The negative 3 goes in for y. So opposite of x plus 2 times negative 3 equals negative 8. So opposite of x plus a negative 6 equals a negative 8. So add the 6 to each side, and the opposite of x equals negative 2. Divide both sides by negative 1 to get rid of the negative in front of x, and x equals 2. So our ordered pair solution would be 2, comma, negative 3. So now we'll look at C and D. So again, steps 1 and 2 are done for us. All of our terms are lined up vertically, and the x's in this case are opposites, so I can just add my two equations. So once I add negative 4y plus 3y is a negative y, or negative 1y. 14 plus negative 11 is a positive 3. So divide by negative 1 to solve for y, and y equals a negative 3. Then, once we already have that answer, y equals negative 3, we want to sub that back into one of the two equations. So I'm putting it back into the top equation. X minus 4y equals 14. Put the negative 3 in for y, so we end up with x plus 12 equals 14. Subtract the 12, and x equals 2. So our ordered pair would be 2, comma, negative 3. And then in D, already lined up, the y's are opposites, so we can just add the two equations. 2x plus negative 5x is a negative 3x. Negative 3 plus 9 is a positive 6. Divide by the negative 3 to get x alone, and x equals a negative 2. Take that negative 2 and substitute it in for x in one of the two equations. I use the top. So 2x minus y equals negative 3. 2 times negative 2 minus y equals negative 3. So negative 4 minus y equals negative 3. Add the 4 to each side. Divide by the negative 1. And y equals negative 1. So our ordered pair answer is negative 2, comma, negative 1. Now in example 2 here, what you'll notice is we need to do step number 2. They already lined up the variables, but we need to create the opposite coefficient, meaning the number in front, for one of the two variables. So if I'm looking at example 2a here, my top equation, 3x minus 4y equals 7. Bottom equation, 2x minus y equals 3. So what I want to do is I'm going to multiply the bottom equation by a negative 4, because a negative 4 times the negative y here is a plus 4y. So then this negative 4y and my positive 4y here would be opposites and cancel. So this bottom equation, everything gets multiplied by negative 4. So we have the opposite of 8x plus 4y equals negative 12. So I don't change the top equation in this case, but the bottom one changed. Now I rewrite them and line them up, and I want to add them together. So 3x minus 8x. So our 3x plus negative 8x is a negative 5x. Minus 4y and positive 4y cancel. 7 plus a negative 12 is a negative 5. So we divide both sides by negative 5, and x equals 1. Now we want to take that and put it back into one of the two originals. I put it into the top. So we end up with 3x minus 4y equals 7. So 3 times 1 minus 4y equals 7. 3 minus 4y equals 7. Subtract the 3, and we end up with negative 4y equals 4. Divide by a negative 4, and y equals a negative 1. So our solution here would be 1 comma negative 1. Now sometimes you may look at it like example B here, where we have 3x plus 5y equals 6 and negative 4x plus 2y equals 5. There isn't necessarily an easy way to get y or x to cancel by multiplying each of the equations just by one thing. So the easy term is, I want to cancel the x's. So if my bottom is a negative 4x, I'm going to multiply the top by 4. The top is a 3x, I'll multiply the bottom by 3. That means I'm going to end up on top with a 12x and on bottom a negative 12x to cancel. So multiply everything on top by 4, and we end up with 12x plus 20y equals 24. In the bottom equation, multiply everything by 3, negative 12x plus 6y equals 15. So now the x's have opposite coefficients, so I can add together my two equations. 12x and negative 12x cancel, so I end up with 26y equals 39. Divide both sides by 26, and 39 over 26 simplifies to 3 halves, or 1.5. Now I want to substitute that back into one of my original equations. So I'm going to substitute this in for the y. So I have a negative 4x plus 2 times 3 halves equals 5. So that would be a negative 4x plus 3 equals 5. Subtract the 3 from each side. Negative 4x equals 2. Divide by the negative 4, and x is a negative 1/2. So our final answer is a negative 1/2 comma 3 halves. So now on the back page, we're just going to do the left-hand side. So one more example C here for part 2. So again, in this case, I have 4x minus 5y equals negative 18. 5x plus 4y equals negative 2. So if I want to cancel the x's, I'm going to multiply the top one by a negative 5 and the bottom by a positive 4. That'll give me on top a negative 20x and on bottom a positive 20x. So we end up with the two equations here, negative 20x plus 25y equals 90 and 20x plus 16y equals negative 8. Add those together and we end up with 41y equals 82. Divide by 41 and y equals 2. Now I'm substituting that back into one of the two original equations. I put it into the bottom. So we have 5x plus 4 times 2 equals negative 2. 5x plus 8 equals negative 2. Subtract the 8. Divide by 5. And we end up with x equals negative 2. So our ordered pair would be negative 2 comma 2. So now we get to example 3, which requires all 5 steps. So the first thing we need to do is rearrange the equations to line up the terms. So I'd want to write them so x and y are on the same side and the number's on its own. So standard form. So the top one, I'm not going to change the order. Leave it as 3x plus 2y equals 8. The bottom one, I want to get x and y to the same side, so I'll add 5x to each side, and I end up with 5x plus 2y equals 12. Now, I have a positive 2y in both, so I just need to multiply one of them by a negative 1 to cancel out my y's. So the top one, I changed all the signs by multiplying it by a negative 1. So I have a negative 3x minus 2y equals negative 8. Plus 5x plus 2y equals 12. That leaves us with 2x equals 4, divide by 2, and x equals 2. Substitute in the x equals 2 into one of the two original equations. So I'm putting it into the top. So I end up with 3 times 2 plus 2y equals 8. 6 plus 2y equals 8. Subtract the 6, divide by 2, and y equals 1. So our ordered pair is 2, 1. Then our last example that we're going to look at together is C. So we have 2x equals 4y plus 8 and 3y equals 5x minus 13. I want to rearrange these so I have standard form, meaning the x and y on the same side. So on top, I'm going to subtract the 4y, so it'd be 2x minus 4y equals 8. On bottom, subtract the 5x, so a negative 5x plus 3y equals 13, or negative 13. Now I want to cancel out the x's. So I'm multiplying the top by 5 and the bottom by 2, so I end up with 10x and negative 10x. So then 10x minus 20y equals 40, and negative 10x plus 6y equals negative 26. Add those together, our x's cancel. Negative 14y equals 14. Divide both sides by negative 14, and we end up with y equals a negative 1. Now we're substituting that back into one of the two originals. So I use the bottom equation. So it's 3y equals 5x minus 13. So put in the negative 1 here for y. Ignore the mess up over here. So negative 1 goes in for y. So we have negative 3 equals 5x minus 13. Add 13 to each side. 10 equals 5x. Divide by 5, and x equals 2. So our ordered pair would be 2, negative 1. So if you want to try a couple extra examples, you have 3 here on the right-hand column on the back page that you can try, along with obviously all the practice problems for today's lesson. Please, as you go through the lesson, make sure that you are showing each step along the way. I know it takes up a little bit of space. And make sure that you are following these 5 steps for all of our eliminations or combinations.